I randomly selected this one from my selection of talks because I think it somehow fits. Has nothing to do with user groups, sorry. So, in case you don't know me, I'm Sebastian. I've been doing things with PHP and to PHP for over 20 years now. I help teams build better software using PHP and related open source projects. Do a lot of open source work. Work on PHP, on PHPUnit, and other tools that hopefully help developers build better software. I have a company that has this year its 10th anniversary. Together with Arne and Stefan, who are also presenting at this conference, I help teams do things better. The final advertisement thingy, and sorry, this is in German, because it's for a German non-profit for the German PHP community that was founded a while ago and is now slowly overcoming the encumbrance of German bureaucracy and is allowed to do things. So we are starting to do things. For instance, come to FrostCon later this year, which is a great event in St. Augustine, which is a nice conference for open source stuff. Anyway, that was my first IDE. Or that was my first development environment. Christmas 1990, I got an Amiga 500 because I wanted one. I'd been begging my parents for a really long time, like I want that thing that some people, other people in the class have at school. And I already had lots of books from the library, and since I didn't have a computer at the time, was writing simple basic programs on paper and figured out it would be really nice to actually have a computer that can run this for me, and because programming on paper is stupid. Turns out that the programming language that came with the Amiga was not that good. It kept me entertained for like 1 or 2 days until I realized that using BASIC to draw things on the screen that move is rather tedious and leads to rather slow graphics. So I tried to figure out how to make it faster, and along the way learned Motorola 68K assembly, learned how to program the Amiga's custom chips to make sound and graphics in 2D, 3D graphics effects in real time. When it comes to programming, I grew up in the Amiga demo scene, real-time stuff, fun times. Nowadays, I expect a little bit more from my development environment than the stuff from back then, which is a rather painful realization every time that, like a couple of weeks and a year, I still go to my Amiga on the original hardware, not in an emulator, real hardware with the real tools from back then, and try to relearn the things that I knew when I was like 12, 13 years old. And back then, I didn't know any better, and back then, I didn't have any better tools, so it's really always a hurtful experience working with those tools from back then. Nowadays, I want something like PHP Storm, or if I do PHP work, I want PHP Storm, because cheat a little bit about that you're not going to get any more advertisements today. This is considered by some to be an advertisement, but it's my honest opinion. It's the only thing that deserves to be called a PHP IDE. If you're not using PHP Storm for doing PHP work, in my opinion, you are in a world of pain, and you should try to get out of that and at least give it a try. Everything else, in my experience, only gets in my way. Don't get me started on that. I'm not going to repeat what was said here because I'm being recorded. I try to be a nice person. But the IDE that was just mentioned is one that regularly comes up in emails, tweets, tickets on GitHub, like PHPUnit does not work with that IDE, and they expect me to fix that. I'm not going to fix IDE integration for you, not even for PHP Storm. But yeah, so that is that. Not paid to say that. But on the other hand, I'm also not allowed to pay for PHP Storm. They just don't want my money. Just gave me a free license for everything a long time ago. Yeah. Anyway, if you already use PHP Storm, that's great. PHPstorm already has some really great static analysis code inspections built in, but that does not mean that you cannot do more with regards to static inspections or getting yelled at about doing things wrong in your code while you're writing that code. That's why PHP Inspections EA Extended exists. Please do me a favor, do not ask me about why this plugin for PHPstorm is named that way. I always find the naming really confusing. Ask that the nice guy who develops the thing. EA Extended is the free version of that. EA Ultimate is the paid version of that. I'm not advertising the Ultimate version. It's the thing that I use, again, because I got it from him for free. And I cannot work without it anymore because it really keeps slapping me on the wrists, on the fingers, when I do something stupid that I should think about. That's rather good. So besides the IDE, there are a couple of tools that I think every PHP developer should know about at least. And the first category of tools that I would like to look at is tools for dependency management. There are two types of dependencies that your software needs to do its work. Those are runtime dependencies. And in the PHP world, the standard for that these days is Composer, and I'm really grateful for this great tool because it solved a lot of problems that we had in the PHP world for a long time. And I would like to take this opportunity for a couple of seconds talk about some of the, I know I'm being recorded, but some of the shit that we as open source maintainers have to deal with every day. And I'm really lucky that I have not yet been threatened with physical violence, that so far nobody has started a crowdfunding in this thing called the darknet to get me killed. And I'm not joking, those things have happened to other open source people. Like, if you do not accept my pull request, I know you will be at this conference next week, and I'm going to beat you up until you accept my pull request. Stuff like that. That is not cool. This is not as extreme as that, but it's a time waste for everybody involved. Like opening a ticket for Composer, your logo is wrong. This is clearly a conductor and not a composer. This wastes everybody's time. And if you want to hear more about that, there's a presentation that you can find on YouTube by Jordi, the maintainer of Composer, where he talks about things like that. It's really scary and frustrating, but it's something that we need to talk about. So what does Composer do? Composer enables you to declare the libraries you depend on and finds out which versions of which packages can and need to be installed. And then installs them, meaning it downloads them into your project, and it also generates an autoloader so that you can use the classes you have just installed. You install Composer like this. Last time I checked, this was the suggested way for installing Composer, which I really hate, because you should not curl and pipe to bash. If you do that, you are basically asking for pain and security breaches and whatever. Don't do that. There is no verification of authenticity and integrity involved here. You basically download something and run it. Some people even do that as root. Congratulations, you may or may not have just rooted your system, and somebody else can do whatever they want with your machine. Don't do that. And something like that happened earlier this year. I really did not think that in 2019 I would have to talk about pair or write an article like that about pair, what happened to pair. I knew that it was still being used by some people, but I was really hoping that it would be dead. But I was also hoping for when this happened that it would not come back up online and would just stay dead. But it came back from the dead. It's like PHP's White Walker or Zombie or whatever. It just doesn't die. Somebody needs to
recycle your channel.
Yeah. Yeah, so somebody is making a joke in the front row about the pair channel for PHPUnit. Every single minute even in 2019, I get dozens of requests to pair.phpunit.de from which you are not able to download PHPUnit for the last 5 years. That's more zombies out there, machines that were set up at some point and continuously, whenever they make a build, try to install PHPUnit via pair and fail. Yeah. Yeah, so live is too short to talk about that technology, so we'll skip that. If you want to use Composer in your project, you basically have to have your project. You Composer require vendor/package name to get the package into your project. You get 2 files created for that, Composer.json and Composer.log, and you have a vendor directory where the downloaded code is of your dependencies. This is what Composer.json looks like. Has a require section, vendor, package name. Please use a version constraint. The star is not a version constraint. Greater than or equal 5.6 is not a version constraint. Those are death star version constraints. They lead to pain and suffering and other negative things. What the Composer does is it reads the Composer.json, resolves the dependencies, and generates a Composer log file. It then reads the Composer log, downloads the dependencies, installs them, generates the autoloader, and you're done. And there are various ways or various degrees of how you interact with Composer files with regard to version control. Composer.json definitely belongs in version control because everybody in the project should know what dependencies you're using, unless you want to surprise your colleagues. And you may laugh, but I've actually seen that. So in a lot of projects, it makes a lot of sense to check Composer log into version control to make sure that everybody on the team is working with the same versions. So you can put Composer log under version control. In quite a few situations, especially in an enterprise setting or closed source software inside a company, it makes a lot of sense, at least in my opinion, to also check in the vendor directory in version control. That gives you the possibility, like a year from now, some auditor comes along and says, okay, you had this business transaction a year ago based on this data. Please prove using your software that your software as it was deployed at that point in time, how it made this decision. Did it actually make this decision, or was there some employee involved that overrode something somewhere, whatever. For that to work, you need to be able to go back in time and actually have a working set of the software, your code plus the actual dependencies that you had in production at that time. Just having Composer log in version control is not enough, because the version of a library that you used at that point in time could have been unpublished by now. Yeah, or GitHub could be down and you cannot get it, or packages is down and you cannot get it, or somebody pulled version 1.2.3 and replaced it with 1.2.3, something that you should never do, but some people do that. And if you really need a reliable and robust way of being able to reproduce the state of the software that you had deployed at some point in the past, that's the only way to achieve that. So Composer is really great for runtime dependencies. Some people also manage their development time dependencies with Composers, and development time dependencies are things like tools such as PHPUnit or phan, php-stan, psalm, and so on. For those kind of tools, I prefer to use a tool called phive. Phive is the phar installation and verification environment. It downloads the phars of tools, for instance, PHPUnit, and puts them into your project. That's basically what I just said. The important thing here is that phive automatically verifies the authenticity and the integrity of the thing that you just downloaded. That's important because that is something that you run potentially as root on your continuous integration Docker container, whatever thingy. That allows you to make sure that you use a PHPUnit binary that was signed by me. Now, whether or not you trust me is something completely different, but this makes sure that you can trust that I created that release. The same for all these other tools. All the other tools that can be managed through 5, they need to have signatures that verify authenticity and integrity, that they come from the known authority to make releases for PHPUnit, for PHPAB, for Psalm, whatever. And the one thing that I'm really hoping for to see at some point in the near future in Composer is also cryptographic integrity and authenticity checks, so that we cannot run into a situation like the JavaScript community had a while back when somebody depublished an NPM package and somebody else replaced it with something that had the same name. Luckily, at the time, it did exactly the same thing, but somebody could have replaced it with something completely different and thereby owning a lot of machines because there's no web of trust built into that. Installing 5 itself is a bit, not really tedious, but it requires a couple of steps because you need to make sure that you get a version of 5 that you trust. Once you have the version that you trust, for that you need to verify the signature yourself. If you're paranoid enough to actually do that, after that, it does that for you. And then you can just do 5 install PHPUnit. It will symlink PHPUnit far from a cache, download, whatever directory in your home directory by default. What I usually do is I use 5 install -- copy to get not a symlink, but the actual file, and I check those files into version control. Because for my projects, I want to be able to just git clone my repo and immediately have all the tools that I need to work on that. Again, to a lesser extent, that also allows me to work on a revision of PHPUnit, for instance, from a year ago with the version of the tool that I was using a year ago. But I'm paranoid. Your level of paranoia may vary. So what Composer JSON is for Composer, 5.xml is for 5. Same semantic versioning constraints. Please use constraints. The star is not a constraint. And so on. And by default, you do not have tools under version control. But like I said, I do that. Now, you may be wondering, should you install tools using Composer or phar? That would be the topic that could be the topic for an entire 1-hour session of a presentation. We don't have that much time, so I just refer you to a Twitter thread that I had at some point. You can read that over there. This is probably the most important tool that you never heard about and that you hopefully never have to use yourself, not because it's bad, but hopefully because it's built into things like 5 and Composer at some point so that you do not need to worry about it. The php-scoper takes or looks at a directory or one or more directories of PHP source code and rewrites that source code so that everything is in randomized namespaces, but still works. You may be wondering why that is, why that would be a desirable thing. Consider the fact you have a project, and in your project you depend on library A, and you depend on library B. And both A and B depend on library C, but in different versions. Currently, that does not work, because that is a version conflict that Composer cannot resolve. Consider the fact that PHPUnit, for instance, or for PHPUnit, for instance, I would really like to use some Symfony components. Currently, I don't do that because that would conflict with the Symfony components when the Symfony project tests their Symfony components with PHPUnit. The YAML package, for instance, in the past, that was really bad. I have preview releases of current versions of PHPUnit available where everything that belongs to PHPUnit and PHPUnit's dependencies is in randomized namespaces, and it works for most of the cases. There's a lot of work being done right now in php-scoper, in better reflection, which is a dependency of php-scoper, that makes this more robust and more reliable. And I really hope that by the end of this year, the default for PHPUnit as a FAR will be in randomized namespaces, so all these conflicts are gone, which is cool. If you're interested in that, there's a ticket for that, where a lot of discussion happens. Different kind of tools, enforcing coding guidelines. Not going to talk about PHP Code Sniffer, because I stopped using that a while ago. I'm using php-cs-fixer. And a lot of other people are using php-cs-fixer. That started as a tool that only did what the name says that it does. It fixes your code, cleans it up so that it conforms to your configuration of coding style. At some point, they implemented the dry run feature, which now allows it to be used in continuous integration. For instance, when you send a pull request to PHPUnit on GitHub, on Travis, I run php-cs-fixer to check whether or not the code that was changed conforms to my coding standards. And if it does not, php-cs-fixer comments on the pull request and says, hey, please fix this. Otherwise, Sebastian cannot read it. Yeah, but it can fix so many things, and it cannot just fix things that are easy to fix, like tabs versus spaces, or where do the curly braces go, and so on. But for instance, it can also reorder the methods in the class. Personally, I prefer to have, as the first methods in the class, the public static methods, followed by the interceptor methods, constructor, deconstructor, and so on. Followed by the public methods that are not static, followed by the protected method, followed by the private methods, and so on. And it can do that automatically for me. It can migrate code to use newer language features of the PHP language. Simple stuff like replacing array braces with just the brackets. That's easy. But it can also detect in certain if statements that the new ternary operator or the space ship operator or the null coalesce operator can be used, and it can do that for you. That's really nice. So I like the tool a lot, and I cannot work without it anymore. Because I find it that for some of the rules that I have in my coding standards, I cannot follow them. Not always, at least. So the tool helps me, not just people that want to contribute. So configuration file for that is .php-cs-dist. It's PHP code in there. And you basically tell it on which directories to run and what rules do you want, and some of those rules can be configured. And then you can run it using the dry run, for instance. And this is rather boring because all files conform to the coding standard. If we break something, breaking is the next slide. If we run it again, it's really quick because it caches. So it only looks at code that has changed since the last time it was run. If we break something, it shows you a diff. And the diff is what it would change, how it would change the code if we were not in dry run mode. So you get a chance to review before it actually does something. Right. Yeah, and if you want to use it in continuous integration, just use it with dry run and set the output mode to check style, and then it's check style XML and all the common continuous integration solutions. They know what to do with check style. They don't care about that it doesn't come from PHP Code Sniffer anymore. Just works. Right, finding problems. In the past, like in the distant past before PHP 7.
Dark ages.
No, the dark ages were when I started doing things with PHP. That was like the late days of PHP 2 and the early days of PHP 3. Those were the dark ages.
I think that's probably okay.
We had like two really popular tools for looking at code to find things, points in the code, locations in the code that are worth looking at because they may be problematic. Those were tools like php-depend and php-mess-detector. These tools do not work with current PHP 7 code, and the projects are at least dormant, if not dead. But that's okay, because we have better tools now. And we have these better tools because a lot changed in the PHP ecosystem. One thing that changed since PHP 7, PHP's compiler uses an abstract syntax tree, and there is an extension that exposes the abstract syntax tree from PHP's own compiler to userland PHP, so you can do static analysis on that. This is extremely fast, and it's always accurate and in sync with the language because it is coming from the language's official compiler. The other thing that changed is that we now have libraries such as PHP parser that are actively maintained by the people who also work on the PHP compiler itself. And that's written in PHP as and gives you a parser for PHP. That's really easy to use, provides a good API to implement static analysis tools. So that's kind of nice. And this is just a nonsense script that has some issues. So we have some code with issues to test our static analysis tools with. I'm not going into detail into most of these. So there's a tool called phan, which uses the PHP 7 extension for the abstract syntax tree. Phan is developed at Etsy, and they use it to do static analysis on their code base. They open sourced it. A couple of people are using it. That has some interesting features. You call phan init to set up configuration for your project, and you can just run phan, and it tells you where something is wrong. And for a while, I was really happy with phan and was using it for statically analyzing my PHP 7 code and looking for problems until I came across Psalm. And in my opinion, Psalm is currently the best static analysis tool for PHP because it not just analyzes your code to find problems like phan can find and php-stan can find, and things like problems like php-mess-detector and php-depend could find back in the PHP 5 days, but because it augments the PHP language through new annotations that you can put in your PHP code to get the benefit of additional typing features that we do not have yet in PHP itself yet. So you can do things like union types and intersection types and templates and generics and things like that, and can express constraints on your variables in comments that Psalm interprets. And PHP Storm is starting to pick up on that syntax and interpret it at runtime while you're developing in your code. And there's a pull request pending for PHPUnit by Marco that adds template annotations from Psalm to PHPUnit's code base. And when you have that version of PHPUnit, if you have in your test things like $foo equals this create mock foo, the type inference makes it possible that it, without you adding additional information to your test code, that PHP Storm and Psalm know that that variable contains something that fulfills the API of PHPUnit's mock object API. So you have methods like expects and so on it. But also it knows that it is of the same type as the original type that you're stubbing or mocking. So that's a union type. And that will just work as soon as some bugs in Psalm have been fixed, which I think were fixed last night. And as soon as there's a lot of movement currently going on. Lots of people are discovering Psalm and start using it. It's most importantly Marco, who has some of the weirdest code in his projects in the PHP world. And if it works for him, it will very certainly work for you or for everybody else. So, and he's working on the pull request, and as soon as that's merged, then A lot of things will be more type safe when writing tests, which is awesome. It was a compliment. Somebody just said he doesn't know if that was a compliment, but it was a compliment. Marco is doing amazing work these days. Well, he has been doing amazing work on his projects and in the ecosystem for a long time, but he's doing a lot of stuff recently on better reflection and on Psalm. And Matt Brown over at Vimeo, where Psalm comes from, does amazing work with Psalm, so it's kind of nice. So life is complicated. PHP, as you all probably know, as PHP developers, can be complicated at some point. And Psalm is a tool that helps deal with that. And this is some of the things that you can get with that. What I do not have in these slides, because these slides are from a presentation that I gave a couple of months ago. Back then, Psalm didn't have this feature yet. Now it has it. It's called type coverage. Think of it like code coverage, but for the type inference. If you have 100% type coverage, then for each and every variable, parameter, and return value, Psalm was able to infer the type. And if that is the case, it can do a lot more reasoning about your code and understand your code and tell you where you may or may not have problems, which is kind of cool. And there's no valid reason to not strive for 100% type coverage in new code, with some exceptions. Those exceptions are when your code calls some weird/bizarre functions provided by PHP. PHP still has some functions in it that have as return value either a bool or a null or a string. And then the type inference of Psalm can only say, okay, I know at that point in time when that function is called, the return value is either a bool or a null or a string, but it doesn't know what it actually is, so you need to help it. And it will suggest that you add an assert statement in there that your code assumes going forward after this function call, this is a string. And if it's not a string, at runtime you get an error, which is good. That is something that you can handle. Probably you've been hiding all these years a bug situation there if you just continue when it's a false or a null and you just assume that it is a string. And Psalm just pointed at this. You need to think about this. And once you've thought about it, once you thought about it, you make explicit through either additional code, like if not is string, throw new exception, or have an assert statement in the code. You make it explicit, yes, I have thought about this. I am aware that this function returns one of these three types. And I assume for the following lines that it is of this type. And if it's not that type, then I bail out. And then Psalm knows how to infer that going forward. That was the question.
Does Psalm adhere to the PHP doc annotations for variable types, or does it have its own type?
So the question was, does Psalm use the PHP doc annotation syntax, or does it have its own? It builds on the PHP doc annotation that you already know, and it adds its own syntax on top of that for things like intersection type, union types, templates, and so on.
But if I do add var string, then it will work.
Yes. Yes. There's PHP-stan, which is a weird hybrid between dynamic inspections and static, dynamic analysis and static analysis, because it to some degree relies on PHP's reflection API, which means the code must be loaded, and depending on the code, whether or not loading it has side effects or not, can be weird. But let's skip over that, I think, because I don't know how much time I have. Yeah. Okay. So that's a tool that I wrote around a snippet of code that I think it was Johann Peter Hartmann sent me like 15 years ago. He said, hey, Sebastian, look at this. I hacked together an algorithm that I found for code duplicate detection. It's good enough for experimenting with it, but somebody should build a tool out of that. So I built a tool out of that, and that became PHP-CPD, the PHP copy-paste detector. And I have seen some amazing things, amazing in the negative thing, in the negative meaning over the years. High score I've seen was like somewhere between 40 and 50% of duplicated code in a project that had several million lines of code. If you have that, in my experience, that is a symptom that something in that company is going horribly wrong. In that case, it was like I was on site with the customer for a week, working with the entire development team. And then at some point, I learned that I was not working with the entire team. One developer was missing. That was the one developer that does not need to learn new things because he already knows everything. That's the developer who does not use version control because version control is something that you do not need. That's the developer who didn't write tests because he's flawless and doesn't make mistakes and he doesn't need tests. And the other members of the team would have really liked to reuse his code, but they did not understand his code, or they could have reused it if it was slightly changed. For instance, maybe a parameter there, or like take that big blob of code in that method and put it into a separate method so that we can reuse it. But he always said no. So they reused his code by copy and paste, and 10 years later, you have 5 million lines of code and 50% code duplication. That is not a situation where you want to be in. To make that visible, that's the only thing that PHP-CPD does. You just point it at a directory or one or more directories, and it analyzes the code. And if you say, by default, it nowadays says shows you the duplicated code. Yeah. It also has a fuzzy mode where it replaces all variable names with the same variable name, so you can see as a duplicate, like if you have the same code over here, but the variable name is $I, I have the same code over there, and the variable name is $J, it still finds that. It just takes a little bit longer. And it finds more then. Yeah. Okay. This is a cool tool that was written by Michi Heuselmann as a master thesis at the University of Rosenheim a couple of years ago. And that analyzes dependencies in your project between various parts of your project. It basically makes dependency hell visible. Right? So it has all the metrics that PHP depend had, like things like afferent coupling, like which is the object in my, or which is the class in my project that most other classes depend upon, or the other way around, to find classes that you want to focus on in testing. Like if the thing that is used the most is well tested by a ripple effect, a lot of other problems already are prevented. So that's a good starting point to figure out where you want to start testing in an existing system. Can also show you who depends on whom, if you're interested in that. This is a different visualization of that I cannot read. Like I know how to read it, but I cannot read it for any decent real-world project because it doesn't fit on the screen. You can also visualize it as a graph. So this is the source code for Neos 404. Is Robert in the room? Robert is not in the room. Okay. If I wanted, I could, but it's recorded. Even if I wanted, I wouldn't do it. I wouldn't say anything bad about Neos, but there's nothing bad to say about Neos. Other than that, this is what it looks like with regard to its dependencies on the higher level, but you can filter that. I still cannot read it. You can filter it a little bit more, and then you see things like, okay, Neos uses something that is called Behat, it's using something that is called Doctrine, it's using something that is called Riak and Mongo and Predis and so on. So you can zoom out and zoom in and see what is being used here. You can also do that over time, and this is sometimes really insightful. So you point it as a Git repository, and for each revision, it draws a graph like that. Don't do that on the entire repo. Focus on one directory or module that you're interested in. Otherwise, it doesn't fit on the screen and takes a really long time to render. But that way, you can visualize, for instance, what the refactoring was about. In case you need to show something. Yeah, last sprint, we didn't do we did one feature less than we used to, but we cleaned up. We did this refactoring. This is what this looks like. The code looked like this before. Now it looks like that. This is better. And here you can see the individual steps in case you need to visualize something like that. You can also use dephpend to express architecture constraints, saying things like, okay, this code is presentation code. Calling into my repositories or calling directly to doctrine or certain PHP functions from that code, not allowed. Yell at me if somebody in a template calls doctrine or my repositories for my entities or something like that. That's kind of neat. Testing. I'm running out of time, sorry. There are testing tools, that's it. I don't have enough time anyway to give an introduction to testing. If you've never seen how PHPUnit is used, there's plenty of presentations on that, including videos on talks.thephp.cc. While we're at testing, though, I would like to talk briefly about infection. Code coverage is nice, but it can only show you where tests are missing. Just because you have 100% code coverage doesn't mean that everything is tested. If you have 100% code coverage, that just means now come the interesting things, right? So how do you find the interesting things? You use a mutation testing tool like infection. Mutation testing tool means you run your test once, get a code coverage report, so the tool knows for each test that is being run which lines of code are being executed by that particular test. And then you look at the tested code and figure out how to break it in an automated way. You mutate it. For every location in the code that can be mutated, a mutation is applied. For each mutation that is applied, the tests are run again. And the worst thing that can happen is that the test still works. Because if you replace a true with a false, or a greater than 0 with a less than 1 or something like that, and the test still works, your tests are not good enough. Your tests are not testing the actual thing. What you want is with each mutation that at least one test fails. And in the lingo of mutation testing means the mutant is killed. You do not want escaped mutants. Every escaped mutant is a problem. Excluding false positives. Right? So that is another tool that you install as a var. It wraps around PHPUnit. You run it. And then it tells you, yeah, I generated 71 mutations. 48 mutants were killed. 0 mutants were not covered by tests. That's good. 9 covered mutants were not detected. That's not good. What is good, though, is that 14 errors were encountered. So the mutation was so bad that PHP crashed. Or ran into a timeout, which can happen in a loop. If you mutate the break condition of a loop or the termination condition of a loop, it can loop infinitely, and it aborts that test after a while. That's kind of nice. And if a mutant escapes, it shows you what it mutated, and then it's up to you to decide whether or not that's okay or not. Usually it's not okay. Finally, some things for runtime aspects. So far we only looked at development time. The first thing is also a development time thing. So a while ago I had this problem that I was working with a team. We had a really nice piece of software that was developed using test-driven development and domain-driven design, and we had really nice value objects and object graphs that contained meaningful objects. And then some new developer came into the project, and we wanted to teach him what the object structure looks like for a certain thing that he was, for a certain business problem that he was supposed to work on. And at that point, I realized that no tool exists that nicely visualizes a PHP object graph for me. So obviously, I built one. So imagine you have code like that. So for instance, you have a shopping cart, you have some items in the shopping cart. Those items have a price, and the price is comprised of a currency and so on. And now you want to visualize that. So you install the object graph library and import the function. And then you can just say object graph dump, give a file name. Depending on the suffix you use here, it generates an SVG or a PNG or a PDF, whatever you want. And then pass in the variable that you want to visualize. And for that code, we get this. And writing that gave me a lot of headaches because I learned a lot about PHP's internals that I never wanted to learn. Because PHP's compiler does not allow you to have an attribute in an object where the name of that attribute begins with a number, does not mean that you cannot have an object with an attribute like that. Because in the constructor you can say something like $name equals 1234, $this, $name equals foobar baz, and suddenly you have an attribute defined at runtime that has a name that is not valid in the PHP syntax. And of course, I need to take care of that. If you're interested in performance aspects, the best tool that I've found so far is Tightways. It's basically two things. On the one hand, it's an open source extension that you can load into your PHP for profiling requests of profiling PHP code execution. It's also a commercial offering as with a software as a service where you can upload basically or stream from production or from your testing environment these traces to their server to have them analyzed, and they give you nice visualization, show you bottlenecks in your code. They know about the most commonly used frameworks, so they can filter out noise in your code that comes from the framework or shows you, hey, you have this bottleneck when it comes for these actions or for these types of requests or whatever. It knows what's going on. That's kind of nice. That's the extension if you're just interested in getting that extension and getting the raw data about profile traces, and then build your own tool on top of that. Some people do that. I would rather give some money to Tightways and have them analyze that for you. There's an open source command line tool that can analyze these traces and give you some insight when you're debugging a performance issue. That's mostly good enough. And at some point I was bored on a train, and then when I'm bored on a train, I usually code weird ideas. And I had this idea for a plugin for PHPUnit that starts the Tightways profiling when a test starts and stops it when the test ends and saves all of that to somewhere. And then, in theory, if you compare those traces, it allows you to find performance regressions while running your unit tests. Final tool that I'm going to mention is Xdebug, the Swiss Army knife of PHP development. If you've never heard of Xdebug or never used Xdebug, you are not really probably a PHP developer. I don't know. It's been around for a really long time. It does everything from giving you nice exception traces when something goes wrong, better implementation of var dump when you're doing something in your browser and you get some nice HTML out of that. Step debugging, profiling, tracing, code coverage, basically everything. Probably too much. I've been telling that to Derek for quite a long time, and I think he's seeing that and has some ideas for Xdebug 3 to break it down into smaller things, maybe. Yeah. But that's that. Once I've published the slides, at the end you'll get a list of links to all these tools that I mentioned. And with that, I thank you for listening to me instead of the person who wasn't here. Sorry I didn't talk about PHP user groups around the globe. Thank you.